Hi folks, Dr. P here. This is a question from the Permutations and Combinations workbook. This is lesson 5, question 6. In this question, 12 face cards are removed from a deck of 52 cards. From the face cards, 3 card hands are dealt. Determine the number of distinct 3 card hands that are possible, which include in A, no restrictions. Okay, so in this scenario here, we're choosing 3 cards from those 12 face cards. There are no restrictions. The order doesn't matter. So this is a combination problem. So in all of these here, it's going to be combinations. Because the order in which the cards are dealt doesn't matter. Does not matter. So it's going to be a combination. So we can write here we're choosing from 12 face cards. So 12 choose 3. We can write it in this notation, or we can use the C notation, which would be 12 choose 3. And if you calculate that, it's going to be 220 different arrangements. In B, now we want to end up with 3 kings, the number of arrangements of 3 kings when we're dealing them from the 12 face cards. Okay, now among the 12 face cards we have 4 kings. Okay, so it's going to be a total of 4 that we're choosing from. We're choosing 3, so 4 choose 3. Or we can write that as 4 choose 3 using the C notation. And this is going to be 4. 4 different arrangements involving 3 kings. In C, now we are dealing 1 queen and 2 kings. Okay, so it's going to be 1 queen and 2 kings. So there are 4 queens among the face cards. So we're going 4 choose 1. And means multiplication, and then we're choosing 2 kings from 4, a total of 4 kings. So it's going to be 4 choose 2. Right? This could also be written, if you prefer the C notation, as 4 choose 1 times 4 choose 2. And if you calculate, so 4 choose 1 is 4. 4 choose 2 is 6. 4 times 6 is 24. So 24 different arrangements involving 1 queen and 2 kings. And finally in D we're looking for exactly 1 jack. So the scenario is 1 jack and 2 that are not jacks. And we're going to use the complement notation here. It means 2 that are not jacks. Okay, so we have 4 jacks among the face cards. So it's going to be 4 choose 1. And means multiplication. And then, so the question is how many non-jacks do we have among the 12 face cards? Well, there's a total of 4 jacks among the 12 face cards. So the number, actually we can even be more appropriate here, use set notation here. So the number of cards among the face cards that are not jacks is going to be 8. And how do I get that? Actually, it's going to be 12 minus the 4 jacks, so 8. So the 8 cards among the face cards that are not jacks that we can choose for the 2 other cards. So it's going to be 8, choose 2. If we prefer C notation, it's going to be 4, choose 1 times 8, choose 2. 4, choose 1 is 4. 8, choose 2 is 28. 4 times 28 is 112 different arrangements that involve one jack, or exactly one jack, as a matter of fact. I hope that helps. Until next time, may the math be with you.